All right, scholars, this is like one of my most favorite lessons. I don't know why. I think it's just because it starts bringing everything together with circles and stuff. But in fact, this whole first page, if you notice, is there anything you're filling in? Why is that? Because you've had all these before. This, in fact, was in chapter 7, and this was lesson 7.6. So this is from lesson 7.6. So quick review. Remember from past notes. So this is just new stuff that you need, well, not new stuff, stuff that you were going to use again. Then I want to make sure we all have the same terminology and stuff down. So let's do a quick remember when. When we have a circle, we can also have central angles. Remember, central angles are just angles whose vertices are on the center. So a central angle, its vertex is on the center. Go figure. Central angle. We also have arcs. Remember, those are the broken pieces of a circle. And that, like here, this would be an arc, arc AC, and then you'd have the larger major arc. And remember, we had some simple things to help remember them. Remember, a minor arc can be named with 2 points, and its measure is less than 180 degrees. And we know, if we know a central angle, the arcs, the minor arc and it are the same thing. Then we have a major arc, and its measure has to be greater than 180 degrees. And so like here we go arc ADC to name it, and we're like, all right, if I knew this was to be x degrees, I know this major arc is just 360 minus that amount. And so we had the major arc, and we also have a semicircle whose measure is equal to 180. And we also had to use 3 points to name a measure arc. So remember the degree measures, we put an M in front. We also solved for the lengths not that long ago. But you need to know the difference of these. So we have to make sure we have them. We also had what's adjacent arcs. Remember, adjacent arcs are arcs that share a common endpoint and they're next to each other. So like R, S, and ST are considered adjacent. This larger arc is also adjacent to the two of them. And that was pretty simple. Now, we also had, and let's keep reviewing back here because I want to make sure we're all in the same spot. We also had the arc addition postulate, which we said sum of the parts equal the whole. And we knew that arc AB and arc BC would add up to the larger arc ABC. But we also know that all the arcs of a circle from beginning to end have to add up to 360 degrees. And that's like how we found out measurements. And we also talked about, now like I said, I'm still reviewing. Have you noticed that? I'm still reviewing. We had congruent arcs. And remember, congruent arcs are arcs that have to come from the same circle or congruent circles. And they have to have the same degree measure. So here, we talked about how arc UV and arc ST were congruent arcs because they had the same radii length and they're both x degrees. So we knew that they had to be the same size. And if you remember in the past, I gave you a small circle and then I gave you a large circle. I said, hey, look, these are two arcs of 90 degrees. Do they have the same length? And we all said no. So we're going to be using the central angle and its arcs quite a bit today. And now, as a result, we have a whole bunch of stuff that works when we have congruent circles. And I want to talk to you about them, and they just kind of fill in really quickly. If you have a congruent circle, okay, so this is the big stipulation, all right, our congruent circles, or if I have a circle, we know congruent central angles are going to have congruent chords. Congruent central angles are going to have congruent chords. Now, why is this the case? Side angle side. Okay, side angle side. Because I know the radii are congruent, and if I know the central angles are congruent, I know the two triangles are congruent. And then by corresponding parts of congruent triangles, they're there. So let's write this first one down. Congruent central angles have congruent chords. Now, what do you think about the other way? Yeah, they're going to have to be the other way too. Now, but this also goes another step. We know congruent chords, okay, have congruent arcs. Now, and I'm also going to say congruent central angles. And now, why is that the case? If the if the chords are congruent, I know then that my 2. My radii are congruent again. So by side, 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 the triangles are congruent. If the triangles are congruent, my central angles are congruent. If my central angles are congruent, I know that my arcs are what? They're congruent because they're the same measure as my central angle. Oh, I love how it's all interrelated. Congruent triangles and just, oh, I love math. God is so good. It's just a neat way of how it interacts with each other. So then we go the other way. And so by the way, the congruent arcs are very hard for me to show here. I would use like 2 marks here or something like that because the chords are already marked once. But look the other way around. I sit there and look what's marked first. The arcs are congruent. Well, if the arcs are congruent, what do you know about these 2 little chords right here? What's going to be so special about them? That's right. They're the same. And if the arcs are the same, I also know what about my central angles. Yeah, I mean, it's just so cool. The angles are the same, so they're all 3 interrelated with each other. So if you have congruent chords, you have congruent arcs and congruent angles. So the last part goes, congruent arcs have congruent central angles, and I'm going to say, and congruent chords. So they're all quick interrelated with each other, and I think that's the best thing ever. So let's use this to help solve for different angles. Now, just like any other geometry problem, mark up your diagrams. So let's mark this one up. It says ray PT bisects angle RPS. Please remember connect the dots so you actually use the right angle being bisected. These 2 angles are going to be the same. If the central angles are the same, they have congruent what? Chords. But we also know if central angles are the same, what do we know about their arcs? Right? They're the same. So let's do first, though, we're going to do the chords today. So let's get the chords. So I know this chord and this one are going to be the same. I love it because we had the congruent triangles. So all we have to do is set them equal. So 6x equals 20 minus 4x. Add the 4x over. 10x is equal to 20. X is equal to 2. Find the length of segment RT. 6 times 2 is equal to 12. I substitute it back in. So if RT is equal to 12, which is this line segment, so make sure you know what they're asking for, what's TS's? 12, right, because they're congruent. All right, let's try some more problems on the other side.